So, in a bit of irony, I'm a computer scientist who does not have a slide today. So, I just thought I'd start off with that bit of irony. My project is about data compression and how data compression might be a reasonable metaphor for the concept of wisdom in a technical environment. Essentially, what I'm really talking about is this notion of what artificial wisdom is about, in a similar sense as artificial intelligence. The way that I'm trying to attack this problem is by considering compression, or the idea that I'm going to distill down a huge amount of data into some kind of underlying truth or truths about that data. Another way to think about it is compression is it's a method of statistical profiling that organizes data in a way that's relevant according to some metric that you've chosen, sort of in an a priori manner. And there are measures that are used to sort of assess how effective that is. And sort of to think about wisdom in a technical environment, you really have to make some pretty strong assumptions. So I went ahead and just defined some things that I think wisdom is or should be in a technical environment. It should be universally verifiable. It should be context sensitive in the sense that it responds to specific things in the environment. It should be dynamic in the sense that if the environment changes, perhaps the underlying truth should also reflect that. And some things that it's definitely not. Oh, sorry. One last thing that it should be is that it should be something that you can grab in reasonable time. It shouldn't take forever for you to get information out of the real world in an underlying truth. Things that should not be or can't be really in a technical world are it can't consider human aspects or age or culture or any of these other kinds of components unless they're embedded in the data itself. So this is kind of the framework that I started with. I have a lot of little results, and I say little because they're probably not flashy, but they're essentially all used as components of some pretty important things in text searching. So, for instance, Google, Yahoo, Amazon, the recommendations that you get on Amazon for different products. These sorts of software applications use these little problems to solve them. So I'll try and describe some of these results without boring you if I can. The first one is I just as a compression method, I took a random sampling technique and took a series of numbers and compressed them in a way that they're easy to compress and decompress. That compression is optimal, and it has some other guarantees that make it useful. The second result is where I take a sequence of numbers that could be dynamically updated in the sense that you can add numbers to that list, you can remove numbers from that list, and that's happening at the same time that you want to ask questions about which numbers are there, where are they, how many occurrences there are of that number. And you might be able to see the relationship between that and a regular web search, for instance. If you search for a word like Java, the number of websites that are talking about Java are constantly increasing or decreasing, moving around from here to there, and you need to be able to identify them quickly. And the third result is actually a pretty surprising little result. It's a situation where you have data that's unsorted. It's completely unorganized in any fashion, and still we show that you can search in that data, you can find out interesting answers about that data without having to sort it. And as time progresses, the algorithms that we've developed sort of automatically and accidentally sort that data. And it responds well to dynamic things and also to static data. So you can be adding and subtracting numbers at the same time as you're asking these questions, and the data continues to be more sorted as time goes on. And we're working on an optimal competitive ratio for that. What that means is that if you were to take the same amount of information and instead of doing it dynamically, if you were to turn it into a static case of the problem, the decisions that you would make would be the same. In other words, there's no advantage to being able to predict in an a priori manner. And the last thing I wanted to say is that I started off saying that data compression was really the metaphor for wisdom. I don't think that's the whole story. I think that there's more to it. I think that the notion of in-time wisdom is very important, but it's definitely not the whole game. And I focused on wisdom in the sense of extracting useful information out of a large set of data, but there are other things that might be wise as well. Algorithm development, heuristic development, wise queries to a piece of software, among other things. So that's what I have.